Okay, let's start recording Elements of Astronomy and Cosmology. The outline, there are four main points: the solar system, the Milky Way galaxy, the early universe, and then some observation telescopes. Just like this is astronomy and this is cosmology about the universe. So, point one, the solar system is 4.6 billion years old. Has four rocky planets. It's Mercury, Venus, Earth, and Mars, and the moon around Earth. And four gas giants. It's Jupiter, Saturn, Uranus, Neptune. Okay. The asteroid belt is between Mars and Jupiter, and the Kuiper belt is out there. This is Pluto out here. Okay? So meteorites come from the asteroid belt, and comets come from the Kuiper belt. The solar system is pretty flat. The planets are on circular orbits, and it's in a disk. Oh, let's skip this one. Skip this one, and then get to Venus. It's the brightest planet at night, besides the moon. It's 0.7 astronomical units from the sun. 1 astronomical unit is distance between the sun and Earth, 150 million kilometers. It's hot at 400 degrees C. There's remnants of atmosphere, mostly carbon dioxide. Rotates in the opposite direction. Actually, the Venus' atmosphere is very thick. It's 100 times the density of the atmosphere on Earth, but it's mostly carbon dioxide. And it has clouds made out of sulfuric acid. 1 Venus year is almost 1 Venus day. It's spinning and going around the sun pretty much same rate. Let's skip this one. We said the Earth interior there's a core, mostly metal iron. There's a mantle, mostly silicates rocks, at hot temperatures up to 5,000 degrees. And the top crust is very thin. That's where we live. We said that the moon, Apollo missions, you see site of a lot of craters, doesn't have an atmosphere. The Grail mission measured the density of the moon precisely so that they could investigate, study the thickness of the crust. And it turned out on our side, on the hidden side, it's not the same. The moon shows always the same side to Earth. It's called tidal locking. In other words, the moon is not a perfect sphere. It's more like a potato, where the density on one side is different from the density of the other, so the moon is gravitationally locked onto Earth. Always shows the same side. Mars, there were the Viking missions and the rover missions the past 10-15 years. There's a thin atmosphere of carbon dioxide. They found water at the poles. This is one of the rovers. This mission was supposed to last less than a year, but it lasted 15 years. Why? Because they thought that the solar panels would get covered with dust, would not function anymore. It turns out on Mars, there are windstorms that clean out the solar panel so that it's still getting the sun. So there is also the Mars Curiosity Science Lab, which can do some science, and spectroscopy and so on. Mars is exposed to solar wind, lack of magnetic field. Methane was detected, We don't know whether it's geological or biological origin. In other words, we don't know whether there is early form of life on Mars. The asteroid belt, this is a spacecraft called Dawn that was sent from Earth to investigate Ceres, which is an asteroid. So the point of this slide is to show you that these spacecraft do not travel in straight lines. They use gravitational pull of planets. So it went from Earth, used gravitational pull of Mars, then gravitational pull of another asteroid called Vesta, then Ceres. Okay, so Jupiter is the biggest planet in the solar system. It contains hydrogen on the outside and helium on the inside. It's pretty big, gravitational giant. This is what attracted the asteroid belt. Galileo spacecraft sent a lot of photos. Has a cloud band of ammonia. You can see it. Has a lot of moons, including Io. The Juno spacecraft is actually sending a lot of scientific data right now. Details to Jupiter and its moons. Like for example, this is close-up of Io. Cassini space mission also passed by Jupiter, sent this photo. This is what is called an ice volcano, just like a geyser. The Ganymede and Callisto contain cores with rock and metal, just like Earth. The Cassini spacecraft investigated Saturn for 20 years, sent, for example, a Huygens probe that landed on Titan, one of the moons of Saturn. Saturn has rings of rock and ice, so has a lot of moons. Titan, one of its moons, has methane atmosphere and methane lakes. Now we get to Voyager 1 and Voyager 2. They were launched about 40 years ago. Voyager 2 is at the outskirts of the solar system. It's crossing the Kuiper belt right now, which extends to 150 astronomical units. Comets come from the Kuiper belt, like the Halley comet that comes every 75 years. It's mentioned that sun's gravity dies out at 125,000 astronomical units. So Voyager 2 will leave the solar system where there's no more gravity at all in about 80,000 years. It's very far away. Okay. That's 125,000 astronomical units correspond to 2 light years. Very good. Right now it's at 150, and this is the end of the solar system where there's no more gravity. Okay, the various missions, spacecraft, I want to observe the solar system, investigate. So Apollo missions, 69, 72, actually Apollo landings that brought back a lot of rocks. Voyager 1, Voyager 2, still going, flyby. Galileo, Jupiter and its moons, Cassini, Saturn and its moons. Rover missions are still on Mars. Stardust, for example, flyby of a comet and return some dust from the comet. Okay, let's get to the Milky Way galaxy. That's our galaxy. So the Milky Way galaxy is a spiral galaxy. The sun is at some 26,000 light years from the center. Know that the galaxy center has a supermassive black hole. It takes 220 million years for the sun to do one revolution around the So you see the various arms here. It's almost like a disk plane. Okay. So there's another view of the galaxy, side view. It's the galaxy itself is 100,000 light years in size. It's about 1,000 light years thick and contains hundreds of billions of stars. The closest star is Alpha Centauri. It's about 4.2 light years from the Sun. The constellation Sagittarius is at the galaxy center. The galaxy center is the site of a black hole. Some well-known constellations, like Little Dipper, the Big Bear. This is the North Star. It indicates the north. The Kepler Space Telescope mission lasted 4 years, sent all of the data, and now they're finding exoplanets. Sent to monitor 150,000 stars in the Milky Way from Earth's orbit, used a high-resolution telescope and CCD cameras. For example, detected over 4,000 exoplanets so far. These are planets outside the solar system. Thousands of them so far. See one here? So when an exoplanet passes in front of its star, the intensity of the star dips a little. That's when you know that there is an exoplanet. And this gives us an idea of how long does it take the revolution go around. Let's skip this one. Then get to the early universe. We said that early telescopes, like Mount Wilson, was a 1.5 meter telescope about 100 years ago. First telescope that used reflection mirrors, not refraction, but reflection mirrors, to avoid some of the chromatic aberrations. Hubble, the scientist, used it to discover galaxies, that galaxies existed. In other words, the universe contained galaxies. Now they have found some hundreds of billions of galaxies. Each galaxy contains 100 billion stars. So it uses some specific stars to determine the distance from those galaxies to Earth. It uses the Doppler effect to determine speed of these galaxies to us. So space-based telescopes above the atmospheric blur, like WMAP. That's for the microwave background, measuring microwave background. This is a photo of the microwave background. It's pretty flat, pretty uniform, 10 to the minus 4. Was discovered by Penzias and Wilson at the Bell Labs. Gives us a temperature of 2.7 degree Kelvin of the cosmos. This is a remnant from the Big Bang, which happened 13.7 billion years ago. Okay? It's an infrared image, WMAP. Okay? Cosmic microwave background. So this is where we are. This is the Big Bang out here. Right. So anti-gravity and dark energy. So the universe is expanding. They found out it's expanding faster due to what is called dark energy. There's an anti-gravity effect. WMAP is out here. This dark energy is not understood. Anyway, makes the universe expand faster. Accounts for 68% of the universe density. Only 5% of the universe density can be observed, is what we see, the planets and so on. Okay, so 68% dark energy. The observable universe is 5%, and the rest is called dark matter. It's gravity. It's a supergravity. Dark matter is an invisible form of gravity. It accounts for 27%. So 68% plus 5% plus 27%, that's 100%. Okay, so our hypothesis is that dark matter is made out of what is called WIMPs, weak interacting massive particles. Have not been observed yet, but they're trying to create them in the lab using huge atom smashers, particle accelerators. So Einstein's concept of gravity is that there's a space-time fabric. When you have a heavy object, creates a trough. Objects that get close fall into the trough. That's gravity. Okay? So black holes at the end of huge stars and runs out of fuel, creates white dwarfs, then becomes neutron star, then at the very end becomes a black hole. So there's a supermassive black hole at the center of every galaxy they found out. There are many, many black holes in each galaxy. They devour everything close by, do not emit light. Okay? So, but black holes have gravity, so you see some stars getting attracted by them, so you know that there is a black hole, gravitational effect. Okay? So, black holes are not understood yet. Observation telescopes. The optical telescopes like the ones at Hawaii. The infrared telescopes like in New Mexico. And then the radio-based telescopes like the one in Puerto Rico. Observation of distant quasars and galaxies. Quasars are periodic stars far away. This is 305-meter radio dish. The Hubble Space Telescope was deployed in 1990. Still up there. Continuous observation, visible, infrared, and UV. Observation of birth of galaxies, supernovae, and so on. When a big star runs out of fuel, it can finish a supernova explosion, and so on. So Hubble Space Telescope could no longer be serviced since the end of the US Space Shuttle program. It's up there, but it's kind of dying. It's approaching its end. It will be replaced by the James Webb Space Telescope. Okay? The James Webb Space Telescope will be launched in 2022. It will have an elliptical orbit 1.5 million kilometers from Earth. This is Earth, this is the Sun, this is James Webb. It will have Earth and the Sun on its back, behind it, and will be looking at the universe without noise. We'll focus on the imaging of exoplanets, trying to find habitable ones. Okay? So gamma ray telescopes to observe pulsar, supernova explosion, dark matter, and black holes. New telescopes, we said that ground-based ones and space-based ones. Now ground-based ones, they correct for the atmospheric blurring using vertical lasers, so they're more effective. The 30-meter telescope in Hawaii over the next 10 years. The 40-meter telescope in Chile, southern hemisphere, completed in 2022. Square kilometer array telescope, piece of it in South Africa, another one in Australia. And the James Webb Space Telescope. Okay? So here we're showing photos of pictures from the Milky Way galaxy taken by Hubble. Colliding galaxies, nebula here. The star nursery, that's where stars form. This is called the Butterfly Nebula, and Sombrero Galaxy, and so on. So here we see invisible jets of energy from at the center of a spiral galaxy. Quasars emit energy. There's a black hole at the center. They emit X-rays, visible, IR, and so on. Quasars too. Okay, exploration of space. Now, the only vehicle out there around Earth is International Space Station. NASA is working on a crew exploration vehicle where you send a crew to the moon by 2024. Then a mission, long trip, living on the moon for several months, then flyby on Mars, and then landing on Mars and bringing back rocks. A summary, we said there's been tremendous progress in astronomy the last 100 years. Solar system, Milky Way, other galaxies, observation platforms like Hubble, Kepler, James Webb, and so on. Exciting time. Discovered exoplanets, looking for habitable ones where life might exist like Earth. So far, Earth is the only habitable planet that we know of. Spacecraft like Galileo, Cassini, Juno, and so on. Outstanding mysteries, not understood. Dark energy is a form of anti-gravity, makes the universe expand faster. Dark matter, is also invisible, is a form of gravity. Supergravity, 27% of that density. Black holes in the lab, they're trying to make them, haven't been successful yet, using Tevatron atom smashing machines. Okay, thank you.